Before you check your work on this quiz, make sure you've tried it on your own. This is on the test, doing something very similar to this. And the kids that just took it in the skinny classes in the morning, they struggled on this question, several kids. So struggle through it on your own when there's no harm, and then watch this video going over the answers so that after you've done it, you'll know where you got stuck, and then what things you need to pay attention to on the test so that you don't have trouble on the test. So the question says a tuning fork is held above a tube with water at the bottom. This is similar to what we were doing in the lab last week or this week. The tube can be adjusted by moving it up and down in the water, and then a student collects data, and they have a 620 hertz tuning fork. So this number right here is telling us the frequency is 620 hertz. And then yesterday when we were going over the lab, we learned that the speed of sound is 340 meters per second in air. So that's our speed. Now, one note, that number, you need to make sure you have it written in your notes, because on the test question like this, they don't tell you the speed of sound. So that's what got a lot of kids stuck, is they were missing a number. They're like, what do? I only have one number. But we always know this. The speed of sound is 340. So we have the equation speed equals wavelength times frequency. So I can plug these numbers in. I put the 340 where my V is. I'm looking for the wavelength, because say, what is the wavelength of sound? So I'm going to leave that as the lambda, which is the symbol for wavelength, and then I'll put the 620 in where the frequency is. So then algebraically, if I want to solve for the lambda, I'm going to divide both sides by 620. And if I take 340, divide it by 620, putting that in a calculator, I get a wavelength of 0.55 meters if I round it to 2 decimal places. So that's my full wavelength. Number 2 says to sketch the wave in the tube to the right when they first hear the resonance. So we learned that if we have resonance in a closed tube, so if you use your notes on the top of page 4, a closed tube has a node on one end and an antinode on the other. And the most basic first point you're going to hear resonance is when you have just one node and one antinode. So the wave looks like this, which to answer the following question, you need to know, the next question, you need to know that that's 1/4 of a wave. So the number 3 says, at what distance out of the water will you need to hold the tube? So they're asking you to find this length of the tube from here to here. So in the lab, we measured it, and then we figured out the wavelength. Here, we're going to find the length of the tube, knowing the wavelength is 0.55 meters. So if that's 1/4 of the wave, and my full wave is 0.55 meters, 1/4 of that, to figure out what 1/4 of that is, I would divide it by 4. So if I divide 0.55 by 4, I get a wavelength of 0.014 meters. So that's not my wavelength, that's my length of the tube, sorry. Then number 4, it says they accidentally missed that first point and they keep pulling it out. This was what I was demonstrating in class yesterday. You can keep pulling it out. You'll hear a resonance everywhere. You have a node on the bottom and an antinode. So this is that first point you hear a resonance. But then the wave is going to continue if you keep lifting it, and you'll get a waveform that looks something like this. This is that second mode of vibration. If you look on the notes on page 4, you still need an antinode at the top. But we have, so here we get an antinode at the top, a node on the bottom. We're going to hear it resonate again here. So we're going to sketch that. This is the sketch that you're doing here for number 4. Number 5 says, what length will that occur? Well, there's 3/4 of a wave here, because we can kind of see there's a quarter there. Here's a quarter, here's a quarter, here's a quarter. So we have 3/4 of a wave. So this tube here is 3 times longer than the original one. So my last tube, that first point we had, it was 0.14 meters. So it's going to be 3 times longer than that. So I'll take 3 times the 0.14 and I get 4.1. Now, when I'm doing all these calculations, just so you know, I've left my original answers in, so you might get slightly off by 1/100th or 2, just because of, depending on where, if you type in 0.14 or I left in the 0.137096. So if your number's a little bit off, that's why. It's just a rounding thing. And then number 6 says, provide an explanation for why resonance occurs. Well, resonance is when you get standing waves forming. On an object, because you're forcing vibrations at the natural frequency. I will tell you the question on the test, it's much easier. It's a multiple choice question. You just have to know what resonance is and be able to pick off the definition of resonance from the test. So it's much easier on the test for number 6. But questions 1 through 5 are almost exactly like this on the test, or very similar to this on the test. So you want to know how to do this.